Welcome back to another explainer, crafted right here at Forge College. Let's grab our magnifying glasses and honestly, maybe a trench coat, because today we are stepping into a brand new role, blockchain detectives. We're diving into the synthesis and case studies of decentralization trade-offs. We're going to take everything we've synthesized so far and put some real-world cases under the microscope to see exactly what makes them tick.
Here's the plan for our investigation today. We'll start at the detective agency, build our case with the evidence triad, decode the metrics, run the numbers, look at a tale of two networks, and then, finally, deliver our verdict. Let's hit the ground running.
All right, part one, the detective agency. Let's do a super quick recap of our trade-offs. As we saw in our last lesson on performance, security, and scalability impacts, when you push a network for pure, unadulterated speed, well, it often creates a highly centralized crime scene by concentrating power. But let's look a bit closer, because here is the absolutely crucial question. How do we actually compare these massively complex networks without just getting buried in technical jargon? I mean, how do we take the pure theory of scaling trade-offs and flip it into comparative, solid judgments that actually hold up under scrutiny? Well, that brings us to part two, the evidence triad. It's time to build our case using a framework you can rely on time and time again. We can break this down into our trusty rule of three. Step one, the metrics. This is the what. Think of these as the literal clues left at the scene, the cold, hard, quantitative numbers showing how a protocol actually behaves out in the wild. Step two is the narrative, the how. This is the sequence of events that ties those numbers to real-world operational causes. And finally, step three, the governance context, the why. This gives us the underlying motive. It explains the rule changes, the upgrade paths, and the economic incentives that, make a network act the way it does over the long haul. Moving right along to part three, decoding metrics. Let's actually examine some of these specific numeric clues left at the scene. Okay, so we have this incredibly intimidating name here, the Herfindahl-Hirschman Index, or HHI for short. I know, it sounds like some rare medical condition, right? But seriously, don't panic. It's really just a financial index tool used to see if a small handful of validators are secretly hoarding all the power. Basically, it measures state concentration by summing up the squared market shares of all the validators. Higher number, higher centralization. Lower number, more decentralized. It's literally that simple. And this right here brilliantly illustrates how we map our numeric clues directly to the network's motives. For example, if we're looking at the validator HHI, the underlying mechanism there is usually delegation rules. And the burning question we need to ask is, are the rewards consolidating? For top-end block share, we're zooming in on leader selection to see if a few validators are quietly controlling the block ordering. And for client diversity, we check the software implementation. Are we looking at a single point of failure? So as you can see, we're connecting the raw data straight into the mechanical design of the network. All right, part four, running the numbers. Let's process the evidence. Because instead of just staring at pretty charts, we can actually run minimal Python scripts on public data snapshots and extract all these juicy insights ourselves. Think of this like a straightforward lab procedure. First, our script reads the basic CSV files for validators and blocks, keeping it simple and totally adaptable to any network. Next, it crunches the math, summing the squared shares of the validator stakes for that scary-sounding HHI calculation we just talked about. And finally, it tallies up the blocks to find the top 10 production ratio. Basically, what exact percentage of total blocks were pumped out by just the top 10 validators. It's an elegant little process, and trust me, it is incredibly revealing when you compare it against historical baselines. But, and this is a big but, as any good detective knows, context is literally everything. When we run these numbers, we have to pause and ask, wait, was this high concentration designed on purpose? Like, some networks intentionally use stake pools, right? That's an intended equilibrium. Or is this an accidental vulnerability, an emergent concentration that the developers totally didn't see coming? Part five, tale of two networks. Let's actually put our framework into action by throwing two networks into the ring, alpha versus beta. Let's contrast their core design philosophies. On the left side, we have network alpha. Now, alpha has a serious need for speed. It prioritizes high throughput, it uses an epoch-based leader rotation and permissive staking. On the right, we have network beta. Beta is the absolute champion of open participation. It features open validators, smaller blocks, and a much longer finality window. So let's look at the actual metrics we extracted.
Point 18. Okay, so this is network alpha's HHI score.
And in the world of conventional index scales, this signals moderate state concentration. Now, when we pair this number with alpha's other metric, a 67% top 10 block share, we get a very, very clear picture. A small group of validators is heavily dominating block production. And that's likely because of that epic-based leader rotation, which tends to hand out back-to-back block production slots to validators who are just highly available.
Now, in stark contrast, take a look at network beta's HHI 0.07, much, much lower. This proves there is a significantly wider, much healthier distribution of stake spreading across the network. Plus, beta has a way lower top 10 block share of just 22%, so power is far more decentralized here. No question.
Our final clue to look at is client diversity. Network Alpha relies really heavily on just one primary software client, which is running like 90% of its nodes. Let's be real here. From a security standpoint, Alpha is a total sitting duck. One single bug or a coordinated exploit in that one codebase could take down almost the entire network in a flash. Network Beta, on the other hand, operates with 3 different clients evenly distributed. It spreads the risk brilliantly and completely avoids that nasty single point of failure.
Which brings us to part 6, the final verdict. We've got our clues, we've got our narrative. It is time to close the case. A good detective never deals in absolutes, and honestly, neither should we. Our final verdicts always have to be conditional statements that weigh the exact trade-offs. Why? Well, because it makes our judgments both actionable and totally defensible. So for Alpha, we'd say, given its high top 10 block share and single client dominance, Alpha has a high operational centralization risk despite its blazing fast throughput. For Beta, given its wider state distribution and multi-client environment, Beta is highly resilient to single-point failures, but it clearly sacrifices short-term speed and performance to get there.
So, if there is one absolutely crucial point you remember from today's explainer, make it this quote right here. Metrics without mechanism are shallow. A raw number, like an HHI score or a block share percentage, means absolutely nothing without the narrative of governance and the mechanics sitting behind it. We literally always have to translate the numbers into cause and effect statements to truly understand the health of a network.
As we wrap things up, I want to leave you with a provocative question to chew on for your upcoming capstone project. What governance features will explain your chosen network's metrics? Get those CSV datasets ready and start applying this triad framework. Thank you so much for joining me on this investigation. If you want to dive deeper into this subject, master more blockchain fundamentals, and explore a whole universe of amazing Web3 topics, you've got to check out forge.college. Keep sleuthing, stay curious, and I will see you in the next explainer.